All right, so can you see my screen well?
Yep.
Okay, good. All right. So welcome back. And this is week 8. So this is going to be the last lecture for this course from this week on. From next week on, you're going to focus on finalizing and finishing your model, and together with a little bit animation elements and apply all the material textures, all that, focus on that one. So in this week, I want to give you an overview of rigging. As the animator, as a modeler, you need to acquire this knowledge. I know some of you already taken the next course, which is character animation. So you already have some experience with that. However, we not actually learning any rigging techniques, which is demands another course for that, in my opinion, because we used to teach that within this course, within the next course. But the rigging can be very tedious, very easy to make mistakes for the students and creates a lot of frustrations or that. It's a bit difficult to acquire. However, uh, we later decided to actually bypass that by actually in the character animation course just provide you with a existing rig that is already functional most of the time to cope with any situation and the condition you might want to throw to the rig. But it's very essential to understand what rigging is and what it does, and so you might need to acquire a lot of the terminology and jargons of that, which is essential for you to understand, maybe helps you for the next course as well. So I decided to introduce that. You are not necessarily get too deep on that, but at least you should know the surface knowledge of that. All right. So the rigging. So you need to build a skeleton. You need to. So far, what you create is the skin, is the facade of the whole model. But to animate that, you need to build underneath skeletons, underneath skeletons, not skins, underneath skeletons to drive the surface. All right, so in the animation. So the primary goal is for rigging, the primary goal for a rigger is to create an easy, intuitive rig for animators to do their job as quickly as possible. All right, so it's so as an animator, as a rigger, you are partaking animator's job, partaking programmer's job, and some even the interface design. So later you will see, you probably already, some of you already experienced that. You have all sorts of controls and handles to actually manipulate the puppet, the digital puppet. So a perfect setup allows extensive control over the character, while it also automatically manage those parts of a character that the animator does not need to think about it. So once you familiarize with the rig, and you can intuitively manipulate that as if you are manipulating a physical puppet. All right. That's the whole goal of that. So you need to acquire some of the concepts, technical concepts of that. So these are the basic jargons so you should aware, should know. Joint, which is the skeleton. Some call it bones. I think in Blender it's called bones or something. Some call it, usually across the other software, they all call it joint. And a joint chain, which is a host hierarchy of that. You need to know what is forward kinematics and inverse kinematics. The acronym is FK and IK. So what is IK handle? And you also need in Maya, particularly, you have a dedicated panel for you to manage that because it's a very intricate, complex system. You need some kind of interface to actually organize that. Sometimes cut the link, sometimes build the link or that. So you need to visualize the whole structure. It can getting very, very complex. All right. And sometimes you need to link up, wind up certain properties to another node's properties. So you need a connection editor in Maya to actually connect the properties. And also, if necessary, you want to not only on top of the default property, you might want to add some customized properties, or you want to optimize the channel box display for you to control the rig. So these are the we go through them one by one. So joint and joint chain is in Maya a skeleton that's made of a skeleton is made of joint nodes. So it represents visually as a ball. On top of that, you have a cone. All right, so that represents the direction. So it's connected that are connected visually by bone-like arrow, so like that. It is a continuous hierarchy of joint nodes that are parented to each other. So you start from the basic one, the root one, all the way go to the tips to the skull or to the tips of the finger and to the toe. So everything is connected, and each nodes they have a previous the previous node is the parent of the child node, but you have a one original node, which is the root node, usually we call it. So in the hypergraph, you will see the visual representation of that by the box, and you will see the linkage of that, the hierarchical structure of that. This helps you to visualize, operate the characters hierarchy in 3D views. The top node of the hierarchy is known as the root joint. All right, so each joint has its own axis for translation, rotation. Mostly it is the rotation that we need to manipulate. So it represents by here. So like that's a hip joint. It's actually when it's rotating the any nodes downward, including the leg and the foot and toe, are all rotated. So it's the rotation. That's why the ball represents. It's the rotation is the most important for us because mostly human body or any animals or that the animated in arcs. All right. So in one of the principle of animation is in arcs. So that's why rotation is very important. And the joint and in Maya attribute editor, you will see that you can set up its flexibility, the degree of freedom by X and Y, Z. You can tick them on and off so that you can confine its rotation freedoms. All right. The joint setting menu allows you to select its rotation option. Orientation lets you to define each joint's local axis and pointing directions. And the radius defines the size of joint before you draw them. So the visual, the size of the joint can be set up. All right. So by default, it's proportional to your current display setting. By default, it's just a certain amount. You can simplify that. You can increase and decrease that. All right. And so as you can see, each joint has its own axis, represented by this color code. So Z is blue, Z is blue, Y is green, and X is red. And by default, if you lay down a joint, you will have this straight sort of orientation. However, we do actually, when we further manipulate the rig, we usually just use one axis to pointing towards the previous joint. That way you align them up, except for the last one, it's still straight. And sometimes you need to also maybe control the y-axis, its direction as well for a certain particular situation. All right, so that's the orientation and the joint axis. So the forward and inverse kinematics there's major two types. So when you rotate or translate one joint, and all the sub joints will in turn rotate and translate accordingly. This is called forward kinematics in Maya. This is very useful method to animate character because in real life, human parts often moves in arcs and rotation as well. So when I first start this learning this 3Ds at the time, we don't have IK, we don't have inverse kinematics. So at the time, when you want to animate it, a puppet, you have to joint by joint. So if you raise a arm, you have to joint by joint to rotate to the position, to the pose. So it's a very tedious job and not quite intuitive, but very tedious. Take a long time to do and the particular animation. So that's why later they developed new techniques. They called inverse kinematics. The inverse kinematics lets you to control a series of joints rather than individually by using the IK handle, moving either the handle or an upper start point. Invoke an inverse kinematic solver that calculates the joint rotation for you. So it automates the process. So you just need to control one handle at the end joint, and that the rest of the joints chain will act respectively, automatically. So that's why they call it solver. It has three folds. So you have a single chain solver, have a rotation plane solver, and spline solver. The definition is here, as you can read. So what does it mean? It means like a rotation single chain solver, that the middle one. So you're starting with the starting joint and ended with the last joint. And then it automatically generates this visual representation of that single chain handle. So you see by the end, you have this handle. So by moving this handle, the rest of the joints will move accordingly. So it's just automatic, all right? But there's a slight difference when you have a rotation plane handle. Usually this type of IK handle applies to shoulder side. So like a shoulder has a limited rotation orientation constraints. So you want to have a bit of a control over its rotation direction as well. So you have a representation of two circles that represents the joint only the whole triangle joint can only rotate this way, only rotate along this way. And the current direction of the bending will represented by the little arrow here. That's that. And the last one is the IK spline handle. Instead of having, so usually the previous two handle only applies to two joints so as you can see, like the elbow, like the knee, you have two major, two articulation, all right? But for the spine, the human spine, you have multiple joints. So you need using this called spline handle. So what it does is starting from a joint and ending joint, you have multiple joints. And once you click that, the solver will insert a curve throughout the joint chain inside. So the curves CV point, control point, controls that will align with the joint's length, so that the curve controls the spline's position. All right, you can use the curve CV to move around, to translate around, so that it will in turn translate the shape of that curve. So this is useful for spine. So in a joint, and also has a little bit the limitation of the rotation as well, represented by two circles. So that way you control the handle. The rest of the joint also move accordingly, but with a constraint by that curve. So you can use that curve. It usually just apply to the spine to to simulate the bending and bowing of a human figure. So these are the three major types. Across this software, 3D software, they're all pretty much the same. They using this three method of IK handle. So the hypergraph is the window for you to show the architecture of all these nodes, right? And that there are connections and in the scene. You can then view and manipulate your object's hierarchy and the dependencies in that window. So it can be getting very complicated. All right. And sometimes using Connect Editor, so you have one node, all its property on the side, another node. So you have a driver and be driven node. You make the connection. So the connection editor provides a node's network information in the side-by-side layout where you can view the two connected nodes in a node network. So the connected attributes in the connected editor appears italic, but non-keyable attribute appear dimmed, and the reconnector overrides the previous connection. That's the when you want to become a rigger, you have to deal with that. But fortunately for you, in this course, we are not getting to that much deep, but you have to know that. All right, you have to. And once you have the rig, you have to bind it with the surface model, the model you created. So this is called soft binding and smooth binding. Some call it smooth skinning. So the purpose is to let the surface points to be influenced by the joint. So you can have a color code information or like a black and white color code info for you to visualize how much the surface skin, especially the vertices, receiving how much influence from the underneath joint. So the wider, the stronger, the grayer. So you have a decay of that. It's a gradually transition to another joints. And the gray area means that they have less influence from the particular joint you are selected, but it has more influence. If you switch another joint, you will see another joint have how much influence casted on these vertices. So going through that is also a very tedious particular process for you to edit. The purpose is to have a smooth transition as possible because when you want to distort the organic surface, that's why we call it organic surface, the organic model. So you want to be as organic as possible. So you don't want to jaggedness, you don't want to sudden breaks or that. All right. And so you can even get into further. Sometimes when you fine-tuning the surface influence, you might want to get into the vertex level, vertices level. So you have a component editor. That's another panel Maya provides you to further edit each individual's vertices, how much the influence it gains from which the joints. So as you can see, this is the list of the vertices. They are all numbered. So in Excel format, so you can see what's the joint name and how much influence is on the vertices, each individual vertices. And the total influence is 1. So it's distributing its influence among those joints. So you can see that the process is sometimes it can getting very complicated, very detailed. All right, that's pretty much about the overview of rigging. Any questions?
Not right now. I may have some later that I will reach out because it looks very intimidating.
But you don't need to worry about it because we are not actually getting into that details in this
Oh,
course. It's
okay.
just for your information. It's just for your information. And so that's pretty about that. Later, I will show you for us what we got in this week's tutorial. We introduced how to use the quick rig of Maya. So once you have a finished model, you use quick rig to actually rig up the roughly. Nowadays, the automation is quite good. And later we will introduce a Mixamo on Adobe Mixamo on the web-based rigging sort of interface, so that you can utilize their motion capture of data to directly not only rig your character, you upload your model to that, and not only rig your character, but also you can apply the motion capture data to that, which is quite fun to play with. So don't worry too much, and you don't really need to get into that details of technique details of that. All
Fair
right.
enough.
All right. So the next one I want to I want to take opportunity to further your study by introducing lots of the stuff. I myself, as I mentioned before, I like freeware free stuff. I advocate freeware and open source, some sort techniques. So you after this course, I presume you will going further if you want to go pursue further along this path, career pathway. You might want to. So I want to fast track you to in this field, in this subject, and so I introduced a whole bunch of this free source. I think it's quite useful. Not that you have going through the hard way of starting from scratch, creating your own models from scratch from single polygons or that. You've been going through that. Now you can fast track that by actually using existing models because you understand the process now, and you don't really need to reinvent it well. Next project you're going to do, you might want to utilize the available open source resources to fast track your building process. And I want to use the whole string, an array of softwares. The first one is MetaHuman, but that one you have to download the Unreal Engine, all its packages, so that you can get access to use that. It can create, it provides you with the interface and can create quite detailed, realistic models and for game to create game assets. So that's a good resource you might want to test, you want to play with. On your personal side, it's actually encourage you to freely download and play with. I can't do that on school's computers. But another one is called Make Human. It's a simplified version of that. It's equivalent of that. So that's the Unreal Engine one. You can download the MetaHuman creator to create very realistic, basic, realistic human with very realistic human skins and materials or that. But that's quite expensive package. If you really want to explore. So, and there's a cheap version of that, which is the Make Human. It's been there for quite many years, and it's for you to. It's free. You can download it to Windows or to Macintosh to play with. Let me just maybe. I don't have it on my system right now. I used to have, but the school's policy kind of restrict freewares. So let's show you what's it look like when you when I was playing with the. Hang on, let me just bring the. Yeah, that's the one. So so there's a once you download and install the open that, there's an interface such as this. That's the recording of my last course, the last record. So you can actually see, you can have a whole bunch of choice. You can have starting with a basic nude model like this. You can define its gender, you can define its skin tone, and you can add it you can add it clothes on top of that, and you can define the details of the shape and the proportions, and whether you want to making it female or male, more muscular or not, and or the body type with it's chubby or skinny. You can have all sorts of control and added hairdressing, added the particular default sort of dress on top of that, and so it's quite easy to come up with very realistic models. So I didn't introduce that early because I don't want you to to cheat, but now that you have been through that, uh, maybe for your next 3D project, you can starting from there. Okay, you can actually cheat a little bit, get around a little bit, and on top of that, you have a basic model, basic shape, human shape, and then you can start from there to further sculpt it into the design shape and forms you would like to play with. All right, so that's a very good free source. And let me just go back to the. All right. Another one is this one. It's a special one from one of the Japanese animator. Maybe he this is for creating a particular style of 3D model, which is a Japanese anime style. You can use that. Let me just show you where the how do I, yeah, so that's the interface. So it's starting with basic model already provided to you, and you can further further fine tune and manipulate. You can even control its eye proportion, shapes. The one of the cool feature I like is that it can allows you to create a very good hairstyle. You can have an interface that for you to create the desired hairstyle and by freehand drawing. So you can see that you can have a freehand drawing of the each from each strand of hairs and start to implement the strand across the skull. And so you can starting with a basic one and further manipulate that. So, or you can just individually draw each strand of the hair. And so you can see that, right? You can change its settings, and you can define different, slightly different facial feature characteristics, and yeah. So once you've done that, you can export it to not to Maya directly. You can export it to Blender actually. Blender using GLB format to do that. All right. So that's another one which is quite good. You can go to their web and download that, install it on your own computer, and have a bit of a play with that as well. And another one is the web-based sculpting interface. It's equivalent of the what's like ZBrush, but not as good. But it's good enough. You can upload it your own model to that web, and then start to sculpting maybe the surface details. But of course, it's better to have a high density models upload to that, and you can sculpt out all the details. So like the dress wrinkles and foldings, and then you come back to Maya. By now, you should be able to and transfer the normal map from the high density model to your low polygon models of in Maya. So that's a good resources as well. and some other new free resources like those laser scanned body type bodies with the dress wrinkles or that. You might want to download that and study, and you might want to mimic study the wrinkles of the dress, and maybe you can sculpt out the similar wrinkles and folds of the dress. I think that's another one. If you want to later on to start from scratch again, you might want to starting with the basic mesh models such as these one. It's quite stylized, cartoons-ish sort of bodies, male or female. Although each body part is not connected, you can customize it and then later merge them together as so that it helps you. I think from this type of free sources, it can maybe save you time and efforts to maintain a good proportion of anatomic accurate generic human body to start with, and then later you can add it on top of that, distort or sculpt it, and exaggerate and characterize the shapes and forms with a very relatively good, accurate anatomic structures. All right, so that might be a good source for you as well. So it's totally free. All right, another free software I want to introduce to you. You can see it's you should play that. You can accessible from this link, and you can see how to use that. And maybe I should play that. It's not so these are the links to demonstrate how to use the Vroid and the human maker. The human maker make human software is now available in Blender with added on. It's free, so you download that. You can actually use that within Blender. The materialize is this one. So this is the software for you to utilize. So within the single interface, you can generate all sorts of textures from a single picture. So like, for example, if you take a picture of a particular surface, you want to generate that from single picture. You want to generate all sorts of other textures. You can utilize this material, this open source material software to generate on-site within the single interface. All right, to generate textures, so you can adjust different colors and blurriness and adjust the height. So it's actually a quite a handy tool, but it's not you have to explore a little bit on yourself to how to control, to get hands on what those each individual property is gonna do with that picture. But it's a good, I think it's a good resources for you to generate various maps. So like we're talking about before, so like the normal map, roughness map, or even ambient occlusion or depth map from a single picture you have, and it can generate a relative according to your current picture and generate respectively of each channels. So you can use that. So I think it's a handy tool to play with. So for you for your final assignment, you might want to do that. All right. So yeah, that's that. All right. So that's the a whole bunch of freewares I would like to introduce to you. And lastly, I want to talk a little bit future about the impact of AI, so that. So when I first started, I remember I watched one documentary about the 3D technology or that. At the time, that was 30 years ago. So the at the time, the developers, the ultimate goal of the developers of those softwares and technologies are saying that in the end, they are envisioned that the software could be so automatic that you don't really need to do the animation so far we are learning all the techniques we are learning. All you need to do is just you have a digital virtual characters there and asking him to do this and that. It will automatically do a very naturalistic movement. So this is the ultimate goal. And there at the time I was thinking that's too far away. That's just dreaming. But it seems like they are approaching this ending quite quickly, quicker than I thought. And these are the recent development of the technology. Mind you, this is also already 5 years old, and the it's already.
And I got to say, I can't stop the movie and video animated. Okay, so we
So
need a new AI animation
So nowadays, the automation
technique
is
that
or it's already quite stunning now. It can with the AI large model learning, and nowadays it can do a lot of the automation quite well. It's by studying training the data, it can generate very convincing very convincing movements like that, so that it can responsive to the virtual environment situation such as this. So even you throw things, uh, the traditional way, you can it still can be awkward, not natural. But nowadays, it can responsive to your as a virtual environment, and you just need to give it a kind of instruction, which direction to go and what obstacle you set it up in the environment. It will actually automatically sort of like that, avoiding each other, avoiding obstacles, and complete the whole uh, movement. All right. So it's kind of scary. It's kind of gonna push us all out of job, even though we are just starting to learning the animation. So it's a yeah, it's absolutely scary. So everybody is under threat actually, but we have to face that. So you need to know that. So like this. Now you just need to define the key poses, all right, and the rest of the in-betweens, the algorithm, the AI will actually generate that. So, but still, it's still the industry will still recruiting animators to do their job, because the real impactful storytelling animation still need human touch. The for generating background animation, it's pretty much can be automated like this, all right, by these softwares. But for more dramatic motions and dramatic animations, we still need human input, human touch of that. So that's the future we're, we're facing. Yeah. So, yeah. So nowadays with the facial animation as well. So we're talking about facial animation with blending shape or that. But nowadays it can be using AI to generate a facial. You probably already, some even already played that face-off replacement, and let the face talk, create your own avatars with different, can do the talk, singing, and facial expressions, or that. Yeah, you can even characterize the automated you characterize the human face into kind of a cartoonish sort of a face. And in a game nowadays, just all the animation can be automated, and you just need to ask the character to go there and pick up a box and go to move it to the other places. All the transitional motions all automatically be done. Things like sports, dribbling a ball, basketball, that with the support of all those training data, and so that in the game development, all this animation used to be done by human by animators. Now you just need to the user just need to control the direction of the movement, the rest of the motions, all can be automated. You can see the automated process of the algorithm, how the algorithm defines the motions. That's the graphic representation of the internal algorithms, the way algorithms are thinking, right? So like in this one, they already have the package of that. Just you need to where is it? So like
Papers with Dr. Károly Zsolnai in computer games.
you need to you just need to
realism in the movement, and for games it is also a requirement to perform these elaborate maneuvers, and it remains very responsive even if we mesh the controller like a madman. See that both the character and the ball's movement is much more lively. For instance, here you
not this one. There's another one. God, where is it? I lost it. Should be.
Dear fellow scholars.
Yeah, this one. I think this one is just like this. You define the pose. You define the pose. The algorithm will.
What's more, this could be super useful
try to automate the animations by the key poses to match the key poses in terms of space and in terms of timing. All the in-between process will be done automatically by that.
Different timings for the movement. Excellent. Of course, it cannot do everything if we set up the intermediate stages in a way that uncommon motions would be required to fill in.
Of course, they still have some flaws and improvement, but that they are getting there. So nowadays you have packages like this one. You can actually cascade the.
Hi there.
You can actually do this. You can use your phone to motion capture by phone now, and then you import it into the software to actually generate the.
There's still many ways we can improve it. So first,
but of course, you have afterwards do a lot of cleanup job. So this video is talking about that. You can do the cleanup job because the original motion capture, you can see it's jitterish. It's not that accurate. So the fine tuning, the cleanup job is also very tedious. Still, you still need to go in there to the nitty gritty of that, to fine tuning and clean up all the errors, all the teeny tiny little bugs and errors of the motion capture file.
Have been determined correctly. Let's turn on again. In the upcoming version, there's going to be a separate.
But these packages are available to you already, so you can start to play with it as well. So it's a good time. It's also a very bad time to learn animation. It's a good time, so you got so many resources, so many free stuff, and so many advanced technology available for you. But on the other hand, it's getting harder the competition is getting fiercer and harder to become good, to be excel, and to try to land yourself with a job or that. So it's equally challenging. All right. So lastly, for this week, so I want you to go over there to start to maybe try to upload your models on that to play with that. The whole idea is that once you upload your model, you can quickly rig the model by just pointing some of the key joint nodes, and then you can use the vast database of its motion capture files to enable your character moving. All right. So where's the next one? Just click that. Yep, that's it. Maximum. Just mix. So you need to upload a model, and let me just try to find a model. You try to find a model to drop that. So you need to upload a character. Just try to find a model from somewhere here. Sorry, I need to take a bit of time to do that. Reject. Yes. So I have a model here. So now you can actually drag, select the chain, go into here, and the wrist, I'm going to here, and the elbow going to here, and the knee here, and the groin. Next. So it start the automatic rigging now. It'll take a while. Okay, it's successful. The next. So now you can apply or try to find appropriate animation for it. I'm not so sure, maybe a martial art kick. So you can See that? Okay, you can try some other stuff. Use the all right. A dancing sequence. All right, so you can have a little bit of control over its energy or all that. All right. You can trim the length of that. So once you're satisfied, you can actually download the whole sequence. Choose the format with the skin, the default setting is all right. And download that. So all right. So you have the model. You can open your Maya. Open your Maya and drag and drop that here. All right, so you have that, but you are running into this. So like the joints here, the size is unproportionally pumped up. So I might just disable the joint. Yeah. Okay. So you have that. All right. So now the rest is just apply the texture to that, and voila, you have your animated character. All right, so you can start to play with that. Any questions?
Sounds good. Gonna try to play with that, see how it goes.
Yeah, that's good.
I'm a little worried, because I'm using, like I mentioned, the Maya 2022.
Yeah,
I'm hoping there won't be
for
any
the task
issues.
we're doing, I can't imagine any particular.
Okay.
Yeah, it shouldn't be all right. Yeah.
Okay, cool.
If you don't have any question, yeah, go ahead. Start to play with the rigging part of that. That Mixamo is a good starting point.
Sounds good.
No worries. See you, Chloe.
Do we, just confirming, do we still have lecture next week, or did you say?
There will be no more lecture. However, I'll be still here.
Oh, okay.
Every time I pop up, and if you have any, so next 4 weeks is for you to interact with me if you have any particular issues and the questions or technical problems, and just pop up, and we discuss from there. All right, try to help you
Okay,
to, yeah,
great. Thank you. No, I
no
appreciate
worries,
that.
no worries.
Alrighty. I guess I'll head off for now too then, and
Yeah, no worries.
thank
Okay,
you.
all right,
All right.
see ya.
Bye-bye.
Just a quick question. So can we put our characters into Mixamo, don't we?
Yes.
What format do they need to go in? Just an OBJ or
FBX, OBJ,
FBX?
yeah, OBJ,
Okay.
it's all recognizable, yeah.
Yeah. And all the animations that are in there, do we have to use the exact one, or can we tweak them while we're still in Mixamo?
Yeah, of course.
Okay.
You can still tweak them as I showed you before. You can have a little bit. It's kind of limited. You have a little just the intensity of that motion maybe, but
Okay.
but you can later download that, export, import it into Maya, and you can even further to tweak it if you like in Maya.
Okay.
Yeah, but yeah, eventually, that's the result. Yeah,
Okay then.
yeah.
And so for our props too, should we combine them with the character or just keep them separate?
Yeah, so for your second assignment,
Yeah, for when we do the animation, like in Mixamo, should we put the props with the character when we animate or take them out and leave them separate?
but it depends. It depends. So it's so if for example, your character is just holding something, right? If because when you rig it, it's preferably without any accessories.
Okay.
Uh, and then when you import it into Maya, you might want to stick, for example, you have a stick attached to the hand, so that will be just always be a child of the head, so it will follow all the translation and the rotation of the hand, so it should be all right.
So,
But
so just parent it to the hand?
yeah, parented to the hand, yeah.
Okay.
So you need to do a little bit of that to attach the. But if it's too complicated, yeah, it depending on the situation. So I can't. There's no general solution of that. Yeah, ideally you have a just empty-handed character to upload it to mix mode to rig it without any accessories, and then back to the Maya, you attached additional items on top of that. Yeah.
Okay then, cool. Well, thank you for answering that question. But yeah, so I'll try and put all the textures on my character and just upload him into Sketchfab so I can take a
Yeah.
screenshot and send it into like the discussion.
Yeah, sure. So for
Yeah.
the next 4 weeks, it's for you. Of course, privately, if you want to ask a question, you just send me email. So if necessary, we have private session. That's all fine. So yeah, next 4 weeks is the opportunity for further interaction between you and me, and between all other students trying to solve the issues that emerge from the process. Right?
Okay, cool.
Yeah.
Well, thanks for today, sir.
No worries.
I'll get going.
Yeah. See ya.
See ya.